Hello students, today we are going to discuss the topic millikan oil drop experiment. The charge of an electron was determined by this experiment. Scientist name is called millikan. So by using this he calculated the charge of electron. So if the how he calculated the charge of the electron, what is this equipment, how he done the experiment, now you can see. So millikan oil drop experiment is used to determine the charge on oil droplet containing the electrons. So the oil droplet containing the electrons, we determined the charge. So the oil droplet along with the containing the electrons is made stationary on which high potential difference is applied. So very important topic, JEE advanced and NEET examinations, it is a very important topic. You can, if you observe the setup, if you understand the setup, the process will be very easy. So if you see the setup, there are the two charged plates will be there. So one charged plate is a positive, so that is anode, another charged plate is a cathode will be there. So top of this equipment, atomizer will be there. In the atomizer, gas molecule, oil molecule will be there. So it is like a spray bottle. So whenever if you spray, no, whatever the atoms are there, they will come outside. Same thing is looking like a spray only. So the oil droplet molecule are very small molecule. That's why it is called as a atomizer. We are calling it as a atomizer. So here inside this one, they have taken the gas molecule they have taken. So whenever they spray the oil droplet, the anode is a perforated anode, small holes will be there. So through the small hole, oil droplets enters into in between the charged plate. So oil droplet doesn't contain any charge here, but inside this equipment, they have taken the gas molecule there. How cathode rays ionizes the gases molecule? Same like here also, to ionize the gas molecule, we are using the X-rays here. For example, H2 gas, they have taken X-ray source. Whenever the H2 gas is passed through the X-ray source, electrons are emitted from the gas molecule. Same thing is happening here. When they allow the X-ray source inside of the gas molecule, the gas molecule is ionized. So electrons are. These electrons are enveloped around. This electron is enveloped around by the surrounded by the ion drop. If you observe the with the help of the electronic microscope in a magnified, if you observe clearly, detailedly, if you see that inside the oil droplets is there, center electrons will be there. So electron is surrounded by the oil droplet is surrounded the electron drop. Electron is surrounded by the oil droplets. So many oil droplets will be there. So with the help of the microscope, how we will see oil droplets is surrounding the electron with the help of the high resolution microscope. That's why they kept the high resolution microscope they kept. So whenever this electron is surrounded, inside electron is there, oil droplet inside electron is there. Electron surrounding the electron, oil droplet is there. If you observe the one oil droplet, so here downward some force is act. That downward force is G. If you see electron downward force will be there. Downward force will be like a mg will be. So electrons containing the oil droplet having the here negative charge. Downward one force is acting. Downward some force is pulling towards this. So it is mg. Upward also some force is acting. Wow. How the upward force is acting? If you observe now clearly here, this is electron is negative charge. Upward, what type of charge is there? Upward anode is there. Upward anode is there. Anode is nothing but positive charge. Electron is a negative charge. Opposite charge some force is there. That is called as the electrostatic force of attraction. Due to electrostatic force of attraction, some force will be there. That is called as a electrostatic force of attraction. Upward direction also one force is acting. Means upward direction one force is acting, downward direction also one force is acting. So both the directions, two type of the forces are acting in you. Two type of forces are acting. Electrostatic force of attraction. This is mg. So now what they said, the next point is the oil droplet is made stationary on which a high potential difference is applied. So, some equal quantity of force are attracting the oil droplet towards themselves. It is attracting. You see, downwards, mg, downward one force is acting, upward one force is acting. So, with the help of the potential difference, he made the oil droplet is stationary. Stationary in the sense, it will not go up, it will not come down. So, it will settle at the middle of this segment. It will not come, it will not. So if you see that means what? These two forces are he made into a balanced forces. So it will not come down, it will not come down, it will not go up. So middle of these charged plates, oil droplet, electron containing the oil droplet is made stationary. Thus means it is a motion. So now you can see that these forces are he balanced stationary by the applying of high potential difference. High potential is applied. So nothing but these two forces are equal. Nothing but these two forces he made it as a balance he made it. From this you can calculate the charge of electron. E is nothing but the charge of electron. E is nothing but electrostatic force. Electrostatic force acting on the electrons. So now we can see E is equal to mg by using this he calculated the charge of one oil drop is equal oil drop containing the one electron is equal minus 1.6 into 10 to the power of minus 19 coulombs. Before he calculated the values like 1.59 like that. But you having the some errors. It is the overall accepted value 1.6 into 10 to the power of minus 19. This is for the charge of the one electron. For example, inside the oil droplets, two electrons are present. So this is the oil droplet. Two electrons are present or three electrons are present. So now that time how we will calculate it? Just this has to multiply with the number of the electrons. If two electrons are present, you have to multiply the 2 with the 1.6 into 10 to the power of minus 9. If 3 is present, you have to multiply with the 3 into 1.6 into 10. Just you have to multiply. This is for the charge of the one electron they are multiplied. For this only here nothing but what? Charge is equal to E, electrical charge. But here 1 or 2 is there. So N is into E. N stands for number of electrons. So 1, 2, 3, 4. If two electrons are present, 2 into 1.6 into 10 to the power of minus 19. Like this, he calculated the charge of the electron. He calculated. We have to remember this formula. Q is equal to N into E. If 2 is there, we have to multiply. 3 is there, we have to multiply with the 1.6 into 10 to the power of minus 19. We have to multiply. Now you can see, by using this, after the millikan oil drop experiment, J. Thomson calculated the charge to mass ratio. Charge to mass ratio is also called specific charge we are calling. So charge to mass ratio, electron charge, E by M ratio, electron charge how much? 1.6 minus 1.6 into 10 to the power of minus 19 coulomb. Mass of the electron is equal 9.1 into 10 to the power of minus 28 grams. By using of the millikan oil drop experiment, J. Thomson calculated the charge to mass ratio or specific charge is equal 1.758 into 10 to the power of 11 coulomb. You take the, you want to convert it into kg, multiply with the 1 kg is equal to 1000. Okay. Now we can see that some numerical, these questions they have asked in the previous IIT and NEET. The question, calculate the charge of 1 mole electron. We know that charge of 1 electron, charge of 1 electron is equal to how much charge? 1 mole of electron. minus 1.6 into 10 to the power of minus 19 coulombs. But the question they are asking the charge of 1 mole of electron. So 1 mole of electron in the sense how many electrons? 1 mole value. 1 mole of electron. 1 mole of electron is equal 6.023 into 10 to the power of 23 electrons. So after 1 electron is minus 1.6 into 10 to the power of minus 19, but they are asking that calculate the charge of 1 more electron. So 1 electron charge is 1.6 into 10 to the power of minus 19 coulomb, negative sign. So 6.023 into 10 to the power of 23 electron charge is how much? So if you do this simplification, you will get the answer 96485.3 coulombs. So 1 mole of electron charge is 9648.53 coulombs. So 1 mole of electron charge is 9648.3 coulombs. So 9648.53 coulombs is equal to 1 Faraday. So 1 mole of electron is equal to 1 mole of electrons is equal to 1 Faraday charge. So question is molar mass of electron. What is the molar mass of electron? We know that 1 electron mass we know. 1 electron mass is equal 9.1 into 10 to the power of minus 28 grams we know. So this is the mass of the 1 electron. So molar mass in the sense nothing but the 1 mole of electron. 1 mole of electron is nothing but what? 6.023 into 10 to the power of 23 electron mass is how much? So 23 electron mass, if you do simplification, 6.023 into 10 to the power of 23 electrons into 9.1 into 10 to the power of minus 28. So we will get 6.6 into 10 to the power of minus 5. Approximately value we will get 6 into 10 to the power of minus 5. 6.022 minus 5 we will get the. How many moles of electron weight is 1 kg? So 1 kg of the electron containing how many moles? We know that 1 electron mass we know. So here mass, number of electron. If you do the unitary method, mass 9.1 into 10 to the power of minus 31 kg is equal, number of electron mass is equal 1. 1 electron mass is 9.1 into 10 to the power of minus 31 kg. But they are asking the how many moles. First we have to calculate 1 kg containing how many electrons. Then we can easily calculate the number of moles. So 1 kg containing how many moles. You do simplification, 1 upon the 9.1 into 10 to the power of minus 31 kg. Okay, this many number of the electrons present in the 1 kg, it will be present. So now what they are asking, number of moles they are asking. Number of moles is equal given number of the electrons upon the Avogadro's number. So 1 upon the 9.1 into 10 to the power of minus 31 kg is equal 6.023 into 10 to the power of 23. Now you will get the number of the moles you will get. By doing this, number of moles, by doing the simplification, you will get the number of the moles of the electron. So n is equal 1 upon 9.1 into 10 to the power of minus 31 into 6.023 into 10 to the power of 23. This many number of the moles present in the 1 kg weight. This is about the millikan oil drop experiment. So next class we will discuss about the discovery of the protons. So thank you for watching this video.